In this demonstration called FPDemo, I am going to demonstrate some of the basic functional programming techniques. To start with, I am going to show you a predicate delegate. A predicate is a function delegate that will point to a function that accepts any number of parameters but always returns a bool. To demonstrate this, I am going to use an array of ints, and I'm going to create a function called isOdd. So I'll say static bool isOdd. It'll accept an int. I'll call it input. And to determine if a number is odd, all I have to do is check the modulus of 2. So if input modulus 2 equals 1, that will be an odd number. So I will return that value. If it's 0, this would return false. So how do I apply this isOdd function to this array of numbers? Well, to do that, I need to use one of the LINQ extension methods known as where. So I can say for each int I in numbers. If I did nothing else to this for loop, it would just simply loop through that list of numbers. However, I want to add criteria by using the where function, and yes, this is part of functional programming. And notice here when I type in where with the parentheses, it's expecting a function that accepts an int and returns a bool, and it's called predicate in this case. Well, it just so happens isOdd accepts an int and returns a bool. Now that int is defined based on the fact that we have an array of ints. If this happened to be an array of doubles, then it would be a double for the first parameter. I'll demonstrate it with a different kind of list in just a few minutes so you can see how the where clause would be structured differently. So numbers where is odd, and because this particular function call is basically a delegate, I don't actually have to supply I as a parameter. It is automatically going to be done, again, because isOdd is a delegate. It'll automatically pass I as that first int parameter. Then I can say console.writeLine I. We will stop the console from exiting quickly with the console read line. I'll hit run. And you can see here, out of the original list of 1, 2, 3, 4, 5, 6, 10, 11, 17, 19, 23, only the odd numbers remain. I could also, like I said, create a different function. This time it'll be a bool. And I'll create a function called isPositive. And I'll say double input. And we'll define positive as anything that's not negative, so 0 would be included. So we'll say return input greater than or equal to 0. Then I can create a list of doubles. And we'll say, just call it doubles, equals 1.23, negative 4.56, 7.89, negative 3.14, 0. That should be enough to give us a good idea of how this works. And this time I'm going to say for each double D in doubles, where, And notice here the is_odd is going to fail because now it's expecting a func where the first parameter is a double. So if I change this is_odd to is_positive, and then I'll do a console write line on the D, I'll rerun the app, and you'll see after the ints were printed, you'll see 1.23, 7.89, and 0, which corresponds to the three values that were greater than or equal to 0. I'm going to put a console write line that prints out a series of equals so we can delineate the output a little better. Now I'm going to demonstrate something known as an anonymous method. An anonymous method allows us to create a delegate basically on the fly. Now this delegate can be any of the custom delegate types where you create your own delegate and then you can point to it, or you can use func, or you can use action as well. In this case, I am going to use func. So I'll say func, and we have to decide what type of delegate we wish to use here. Let's carry over our circle area function that we tend to use a lot, and we'll use the definition, double in, double out. So that'll be the definition of our delegate. Then we are going to create a delegate object from that func delegate, followed by an equal sign, and then in this case we will say delegate double radius, and instead of pointing to an actual function, what we will do is define what that function does within these curly braces. So now we've created a delegate called del. As you can see here, it is a delegate that accepts a double and returns a double. And we use this inline delegate definition where we define the parameter name for that first input parameter, and then we return a value of the output parameter type. So this would be very similar to creating a separate function called area circle, or circle area, where we accept a double and return a double, except we've defined the entire method in line. Now this again is known as an anonymous method. If we were to run this code, we would say console.writeLine, excuse me, we'll say area, and we called it del. We'll pass it 1, 2, 3, 4. We run. You can see here we get the area, 478.3879, etc. So again, by itself, this particular technique isn't used a great deal. However, when we start tying these concepts together into pure functional programming, you will find that anonymous methods and lambda expressions are actually used quite frequently. Let's put another separator after that console write line. And now I'll start demonstrating some pure functional programming using lambda expressions. If we wanted to create a function that simply doubles or triples a value, we could start with this definition. Again, we're going to use func, so we don't have to write out an entire delegate definition. In this case, it's going to accept an int and return an int. And I'll call this multiply by 2. And the definition of multiply by 2 is again going to be something we do in line. So we'll say equals, but instead of saying delegate here, we are going to create a lambda expression. Now with the lambda expression, what immediately follows the equal sign is the list of input parameters. Typically, they will be surrounded by parentheses as such. Then you define what those parameters do. Using the arrow operator, we are going to say x times 2, and then semicolon. So let's break this down. We have a delegate definition called multiply by 2, and we're assigning it a function that accepts a parameter called x such that it returns x times 2. And to call this particular function, it's just like calling any other delegate. So I will copy the area code from above. We'll say double. Let's create a temporary variable called x. We'll set it equal to 10. And we'll say doubled equals 1. We'll say x, and then multiply by 2, x. So now we are going to use, let's see here, x. Oh, we already have a different x. Yep, we declared it right here. Can't do that. We'll call it y, or better yet, we'll just call it num. That way we don't interfere with a function we may use later that we define a y. Let's run the code. You can see here, 10 doubled equals 20. Another way of writing a lambda expression would be to accept multiple parameters instead of just one. Now, to do that, we simply have to enlist a different func definition. So in this case, we'll accept 2 doubles and we'll return a double. And we'll call this one multiply together. And we'll set that equal to x comma y such that x times y. Then we will say, double val1 is equal 1, 2, 3, 4. Double val2 equals 5, 6, 7, 8. And then I will make use of the console write line I already had. This time I'll say val1, val2, and then we'll say multiply together val1 comma val2. And I'll put these on a second line so you can read the whole thing in one shot. So you can see here we have a func delegate that's going to accept 2 doubles, return a double. We're calling it multiply together. It accepts 2 parameters, x and y, and again they must map to double and double, such that they return x times y. Then I create my two doubles here, and then I execute the delegate thusly. Run the code again. You can see 12.34 times 56.78 is equal to 700.6652. Now, these lambda expressions can be extended so they do more than one operation rather than just simply returning a simple value based on the input arguments. We can do complex if statements. So if we wanted to, we could implement a compare to function, for instance. So we'll say func string, so we're going to accept two strings, and we'll return an int. And we'll call this one compare to, set it equal to, pardon me, hit the wrong key, string str1, string str2, okay, and then after the arrow, I will use curly braces, and at the end, a semicolon. So now what we have to do is define this particular method so that it will return an int, no matter what the results of these are. So first we're going to check to see if they're both null. So if str1 equals null and str2 equals null, we'll say return 0. They are equal. If str1 equals null, then we'll return -1, making the assumption that a null value is always less than a real value. And let me back up here just a little bit. If you're not familiar with the compare to function, basically it has three possible return values. 0, meaning the two inputs are equal. -1 indicates the first parameter is less than the second, and a +1 indicates the first parameter is greater than the second. So in this case, we're saying a null is less than anything that's a valid string. We already covered the case where both are null. Now we're checking to see if str1 is null. Well, we have one more check for null, and that is if str2 is null. We return a 1. And then finally, we have to compare the contents. Well, I'm going to make use of the built-in compare to function of string so that I can say return str1.compare to str2. And that will effectively compare string 1 to string 2. So then I can say console.writeLine, and then we'll say compare to. Let's put these strings in apostrophes so we can see them printed out clearly. And then we'll put the result there. So we're going to have to put in some values. So we'll just say ABC, and then we'll say 1, 2, 3. Will be the two things we compare, and we'll say compare to and I'll just copy these strings again. So I don't have to create two temporary variables for the strings. I'll hit run again. And in the ASCII character set, or the default character set, all numbers 1, 2, 3 come before letters like ABC. You can see that if you bring up CharMap and I'll bring it up here off screen. I'll move it over. You can see the numbers in Unicode, like in this case it says 31 for the 1 and 30 for 0. Now these are in hex, so it's not really 30, it's 30. Comes before A, which is 41, which also comes before the little a, which is 61 in hex. So that's why the 1, 2, 3 is less than ABC, or in this case ABC is greater than 1, 2, 3, and that's why it returned a 1. And if you're curious how to bring up character map, you can simply do the Windows key R, type in CHARMAP, and that will return the character map. Okay, that concludes what I want to demonstrate with the basics of functional programming. Now, we are going to enhance our knowledge of this topic when we look at the link to objects and link to XML code later on in this course.